Friends, in this video, let's see another fuzzy rule simplification. So, in our previous video, we have done with if and else, and now we are going to deal with if then else. So, also in our previous problem, they are already given the relation which we need to be computed, and here we need to find out the relation and then we have to proceed for the computation. So if we see the rule, if distance is long, then drive at high speed, else drive at moderate speed. It is in the form if x is a, then y is b, else y is c. If this is the case, the relation for this rule is A Cartesian product B and A complement Cartesian product C. So, if we observe the question, we will be knowing that x is distance and A is long. So, long distance will be our A, and y is drive and high speed will be B. High speed will be B, and obviously C will be moderate. So moderate speed will be C. Wait a minute, here already given, right? So this will be our A and this will be our B and this will be our C. Then our relation becomes our R is long distance, let me use LD, into our B is high speed, HS, union, long distance complement, and moderate speed, MS. So now they are asking us to compute this relation. Okay. So now let's find the Cartesian product of long distance and high speed. So take long distance as a column vector, that is 0.1, 0.3, 0.7 and 1, and high speed as row vector 0.1, 0.3, 0.5, 0.7 and 0.9. Now see. Compare this 0.1 with this 0.1, 0.3, 0.5, 0.7, 0.9 and write which is minimum. If you compare this 0.1 and this 0.1, 0.1 is minimum, and 0.1 and 0.3, 0.1 is minimum, and 0.1, 0.5, 0.1 is minimum, and 0.1, 0.7, 0.1 is minimum, 0.1, 0.9, 0.1 is minimum. Done. Now let's compare 0.3 with all these. So 0.3 and 0.1, 0.1, 0.3, 0.3, 0.3, 0.3, 0.5, 0.3, 0.3, 0.7, 0.3, 0.3, 0.9, 0.3 is minimum, and then 0.7, 0.7, 0.1, 0.1, 0.7, 0.3, 0.3, 0.7, 0.5, 0.5, 0.7, 0.7, 0.7, and 0.7, 0.9, 0.7. And now 1, and compared to 1, all these are minimum, right? So you'll be writing 0.1, 0.3, 0.5, 0.7 and 0.9. This is our Cartesian product of long distance and high speed. And then next what we have to find the complement of long distance, and then the Cartesian product of complementary long distance and moderate speed. So now let's find the complement of long distance. Here itself I will find. So LD dash will be, so 1 minus 0.1, 0.9, 1 minus 0.3, 0.7, 1 minus 0.7, 0.3, and 1 minus 1, 0. So now let's perform Cartesian product with moderate speed. So now we are going to perform this. So our LD complement is 0.9, 0.7, 0.3, 0.9, 0.7, 0.30, and our moderate speed is 0.3, 0.8, 0.6, 0.4, 0.1. 0.3, 0.8, 0.6, 0.4, 0.1. So now let's find same way. Compared with 0.9, all these are minimum. So now let's write all those as is 0.1, 0.8, 0.7, 0.4, 0.1. Now 0.7 when compared with 0.3, 0.3 is minimum, and 0.7, 0.8, 0.7, 0.7, 0.6, 0.6, 0.7, 0.4, 0.4, 0.7, 0.1, 0.1. Now 0.3 with 0.3, 0.3, 0.3 with 0.8, 0.3, 0.3 with 0.6, 0.3, 0.3 with 0.4, 0.3, 0.3 with 0.1, 0.1. Now 0 is less than all this, so we will be writing 0, 0, 0, 0, 0. Yes, done. Now we have to compute relation R. R is our cross product of long distance and high speed union long distance complement cross product of moderate speed. So this will be the long distance, that is 0 0.1, 0 0.1, 0 0.1, 0 0.1, and 0.1. Next 0 0.1, 0 0.2, 0 0.2. So 0 0.1, 0 0.1, 0 0.1, 0 0.3, 0 0.3, 0 0.3, 0 0.3, 0 0.3, 0 0.3, 0.55, 77, 79. 5, 0 0.5, 0 0.5, 0 0.7, 0 0.7, 0 0.7, 0 0.9. This union 0 0.3, 0 0.8, 0 0.6, 0 0.4, 0 0.1, 0 0.3, 0 0.7, 0 0.6, 0 0.4, 0 0.1, 0 0.3, 0 0.3, 0 0.3, 0 0.3, 0.1, 0, 0, 0, 0, 0. So union means we have to take the maximum. So 0.1 and 0.3, 0.3 is maximum. 0.1 and 0.8, 0.8 is maximum. 0.1, 0.6, 0.6 is maximum. 0.1, 0.4, 0.4 is maximum. 0.1, 0.1, 0.1 is maximum. Now 0.1, 0.3, 0.3 is maximum, 0.3, 0.7, 0.7 is maximum, 0.3, 0.6, 0.6 is maximum, 0.3, 0.4, 0.4 is maximum, 0.3, 0.1, 0.3 is maximum. And now 0.1, 0.3, 0.3 is maximum, 0.3, 0.3, 0.3, 0.5, 0.3, 0.5, 0.7, 0.3, 0.7, 0.7, 0.1, 0.7. Now 0.1, all the zero side will be written all these. 0.1, 0.3, 0.5, 0.7, 0.9. So yeah, this is our relation matrix. Thank you.